Alright, so our last page that we're going to be working on today, on the back we're writing two variable inequalities from graphs. So when we're writing two variable linear inequalities from graphs, meaning straight lines, we're going to be using the formula y equals mx plus b. Yes, we're going to be using slope-intercept form. So in order to do slope-intercept form, we need to find our slope, we need to find our y-intercept. So on my first problem here, we'll let number that 1, we're going to find our y-intercept, which is the point where it crosses over the y-axis. I can see that it crosses over the y-axis here at 0, so my b value is 0. Then I need to find my slope. In order to find my slope, I need to use my perfect points. I do have one perfect point here at my y-intercept. I also have another perfect point here, another one there, right there, and then one more at the very end. Now I know that I can use any two perfect points in order to find my slope, so I'm going to just choose my closest two here and draw my slope triangle. Now my line is pointing down, so I know my slope is going to be negative. And then my slope I can find using rise over run. The rise would be 1, 2, 3. So I've got -3 divided by 1, 2. So my slope is -3/2. Now looking at this graph, I can see that my line is a solid line. It is not dashed. So I'm going to write that it is solid. And then the shading is above the line. If I pick a point on this line and go up, I can see that all of that is shaded, so my shading is above. Now I can look up here on the other side of my guided notes and see that when I have a solid line and the shading is above it, I'm going to be using greater than or equal to. So in place of my equals sign in y equals mx plus b, I'm going to make this actually y is greater than or equal to mx plus b. So we're going to be using a greater than or equal to symbol here. And then when we're substituting in, let's go ahead and just substitute into our y equals mx plus b. Our y value stays the same, so we're not going to be changing our y value at all. Y is greater than or equal to m. Our m is -3/2, that's our slope, -3/2. X, our x stays the same, plus b. In this case, our b is 0, so we would say y is greater than or equal to -3/2 x plus 0. But of course, we don't need to write the plus 0, so we would just say y is equal to, or greater than or equal to -3/2 x. Now let's go ahead and work on this next one here together. We'll call this number 2, even though I don't have numbers on here. So we're going to graph our inequality here. Once again, we're going to use our slope-intercept form. So we're going to have y equals mx plus b. We need to find our b value, where it crosses over the y-axis. In this case, once again, we're crossing over the y-axis at 0. Our m value is our slope. I can see that my slope is pointing down, so it's going to be negative. So let's go ahead and just pick perfect points. I've got a lot of perfect points here. I'm not going to highlight all of these, but we can see that our perfect points are where we have a vertical and horizontal grid line crossing over our line. So my slope, I can pick any two. We're going to pick just these two right here that are the closest. So our slope is down 1 to the right 1. So we have m equals 1 over 1. Now I can see that my line is dashed, which tells me that that line is not part of our solution. And then our shading is, again, above the line. So that tells me that we're going to then be using a greater than symbol. So not greater than or equal to, just greater than, because we have a dashed line. So our inequality, we've got y is greater than mx plus b. Our m value, we could simplify this to -1. So we would put -1 x plus our b value of 0. But we can go ahead and simplify this a little bit because we don't need to put the plus 0, just like in our first example. And then we also don't need to put our negative 1. So a coefficient of negative 1 is not necessary. So we would just say y is greater than or equal, y is greater than negative x.